So, welcome to the first stream of 2023. Wow, time flies when you're having fun. We have been focusing a lot lately from the Unison core team on the cloud. There's a lot of really exciting stuff happening. So, I wanted to tailor some of the projects and like community library development towards that because I think a lot of exciting stuff is going to be happening in the near future. So without giving too much away from, I think, what Paul and the cloud folks are going to announce in the near future, I want to talk about the local remote interpreter. So right now, in order to kind of get experience with the remote API, you can use the local interpreter of the remote ability. And it's a pure interpreter. It serializes all of your remote tasks, runs them, and returns you a value. But you can still get experience like using the remote API, and it's pretty useful. And one of the things that I found challenging when we were writing about distributed data sets in Spark, that example article was, we talked a lot about bringing the computation to the data versus bringing the data to the computation and potentially moving across like network boundaries and locations. And that sounds really good in theory, but in practice, if you're working on like a flat map function for your distributed tree, it actually gets a little bit finicky trying to think about like where the computation is relative to the data. And I thought, just from a learning perspective, it would be so cool if we started to build tooling around helping to understand where a task has been forked and when it has been awaited, and potentially what that looks like, even in terms of locations. Now, the local remote interpreter can only do one. You get one location. You get location.current, your computer. But in the future, I know Paul has talked about wanting to build a version of a local interpreter that simulates having multiple logical locations. So you do get more of that like robust, distributed feel, even from like a local interpreter. Does that all make sense? Yeah, okay, cool. So one of the things we recently added was the ability to draw mermaid diagrams in our documentation format, which kind of opens up the door for more programmatic drawing of the local remote interpreter into the documentation format. So like, this is really cool. And when I saw Alvaro's library, the mermaid library, and how it can be expressed in Unison code, I thought like, wow, this could be a step towards, doing some sort of, as a task is forked, you draw a line, and combining that with the existing remote ability. So this is the dream. I've written a plan, which may or may not work. So let me share my screen. Share my screen. Do y'all see giant screen? Yeah? Is it too wide?
Pretty wide.
Pretty wide.
Okay. I wonder what the easiest... Like it's unreadable wide, like the text is too small. I wonder...
Can you share
Yeah,
just...
you got the owl. The text is pretty hard to read.
Is it any better?
One of my favorite owl-based memes.
Yeah, that's better.
Okay. So what we want to be able to do is use the mermaid library to visualize remote computations. And what we're going to do is we're going to draw a box to represent a node, and then we're going to draw the rest of the owl. We're going to just do distributed tracing or whatever. I don't know. Profit. We'll figure it out. We have smart people here. So that's the goal. And I've been exploring like what the desired kind of mermaid diagram type looks like. And the one that I've settled on for now is the flowchart API, which allows you to do something like this, where you've got a location, you got your root task, you fork two tasks, you await them, and then let's say you wanted to fork another task to another location. Hopefully we could programmatically represent that. Maybe that task does other work, awaits them, and then sends the data back. Like that's the kind of information that I think would be valuable, because observing computations in a system is hard. So the first thing we need to do is contribute to Alvaro's mermaid library, because right now it supports sequence diagrams, but not necessarily the flowchart API. So we'll take a look at the mermaid diagram library first and be good stewards of the ecosystem and attempt to contribute back. But fortunately, Alvaro is here. So, yeah, the goal of kind of...
A high level question or observation, I guess. You'll have to actually run the program to be able to generate this, right?
Correct. Yes. Yeah. So my...
Everything's monadic, I guess.
Yeah. My
Okay.
idea, I did like a little spike just using the sequence diagram, the existing API, which looked really weird and had an off by one error. But the idea is to just change the local remote pure run interpreter to return the result of the computation and a diagram type. So you're returning both, and then from there you can like turn the diagram into a documentation blob. So we're just kind of decorating the run of the remote API.
Cool.
Yeah, that's the goal. Draw a box, draw the rest of the owl. So in this README, I go into the sort of thought process of like why I wanted this graph API and what I thought would be acceptable even as like an MVP. There are some real challenges with just, do we want to just represent that tasks happened in a location versus this task happened and was awaited later than this other task? Like there's some complexity there that we can make some decisions about in the future. But for now, I figure a good thing to do would just be to make sure we can represent the graph API in Mermaid. So with that in mind, I'm going to head over here to a live share. And let me open up a live share link so folks can, if they would like, join in. Put this in the chat. Okay. So I was looking at Alvaro's mermaid library, and I noticed it's separated just by namespaces, so we'll probably create a namespace called flowchart and start doing our work in there. But we'll try and kind of keep to the conventions of what it looks like.
So last night I got I don't know, I'm curious, and I started experimenting what a flowchart thing would look like. So I have sort of what could be the starting point of this. I don't know if
Yes.
it'd be more instructive to sort of do it from scratch, or should we start with...
No, we should definitely stand on the shoulders of giants here.
Okay, I just have it on a Scratch file.
Yeah.
I wonder what the best way to share it is. Do I just send it on the Discord chat?
Yeah, you could do that. Gosh, I wish we had our gists command linked up to the
Or
Unison
yeah,
share.
I can put it on a gist.
Yeah, I think the gist, you have to go through the Git API. Maybe Cody and Stu can weigh in.
I've never used that. What are you talking about? A Unison gist or a GitHub gist? I guess.
A Unison gist, but
Is that what Elro was talking about?
oh yeah, that's right. Gist has an original meaning.
Then?
Yeah, no, I just put it on a GitHub gist.
Ah,
But I'm
perfect.
trying to figure out how do I send a text? Oh, here it is. Okay. Oh no, that's the general one. Oh yeah, we are on the general one. Okay. There.
Okay, let's take a look at this. Ooh, yes. Okay. Node shape, orientation, node ref. Is a node ref like the name of the node or a name and an ID?
It's just the ID.
Ah, okay, cool. Cool. Very cool. Name, label, shape. Okay, so a node.
You might want to make the text a little bigger.
Yeah.
Yeah.
Oh, this is beautiful, Alvaro. This is wonderful. Okay, unique type flowchart node. Node has probably like a label and a shape. A node can also be a subgraph. Ah, okay.
So a node is kind of like like metadata about something that can be referenced as an endpoint on a link.
Yeah. Okay. Awesome. Okay, and cool. You've got the subgraph. Abstraction represented too. And so a subgraph, it is a label, the orientation, and just a list of nodes. Okay, cool.
Yeah.
Cool. Got a little nice recursive data type here. To text, awesome. So that'll be good for writing the actual diagram. So what is the difference between a link and an arrow? Or link style and arrow style?
Link style is the line, so it could be solid or dotted. And the arrow style is whether there's even an arrow shape or there's an X or a circle
Gotcha.
at the end.
Awesome. Okay, perfect. Yeah, this is beautiful. Okay. So in terms of the hierarchy, is element the kind of like top level data type, or is it
The top level is flowchart.
this one?
111. Yep.
Got it. Okay, so it goes flowchart is a list of elements and a map of text to node.
Yeah, the map there is a way to keep track of the metadata for a particular node. So this is a little different from how it is on Mermaid, because on Mermaid, on any node or any link, you could specify metadata for a node. But in this case, all the metadata, in order to be specified only once, I keep it on a map, and then all of the links only reference the node ref.
Okay. 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 Very cool. All right, I'm going to grab this and we're going to put this.
And I wrote it assuming we would be CD'd into the Mermaid main.
Gotcha. Okay.
But yeah, you can put it wherever, as long as the
Okay, let's go see. All right, I just pulled this before the stream, so it should be relatively up to date. All right, and let's see why The UCM is mad. Oh, it's because there's a bunch of helpful scripty bits from the gist. Okay. Okay.
And to test it real quick, you can run main.
Wow. Okay. So this is working. This is amazing. Let's take a look at what it looks like. Cancel. Flow chart. Oh, it writes two flow charts.
Oh, that main, I made it right too.
Gotcha. This is incredible. Great. Yeah, we have like basically enough to get started. This is fantastic. Because yeah, even for an initial like, can we draw a box representing a pure computation? The things we need are a subgraph and the ability to draw a box. And it looks like we could do that. So, snaps for Alvaro.
Although the rendering of subgraphs I haven't implemented yet, so
Okay.
probably have to do that
Okay.
as part of this.
Gotcha. Well, let's start there. Let's take a look at main. Yeah. So,
Well, one thing I'd like to mention regarding the syntax, this won't look as clean as actually writing mermaid syntax right on as text.
okay.
The only benefit of this is not so much to have better syntax than mermaid, which it doesn't. It's just the fact that you can do it programmatically
Yeah.
as a result of some computation.
Yeah.
So we are giving up a little bit of the syntax for the benefit of being able to do it programmatically.
Yeah, I figured looking at the syntax for the mermaid, like the whole spec, I knew we'd have to make some trade-offs there. But, you know, my primary goal is just like for learning materials, right? Like, is it enough to get people visualizing the fork join model? You know, I think that's still a huge win. So we want to do something like in the library, do you just say subgraph and then
I don't think I have subgraph implemented for that usage. Like I said, DSL. I think only link and node at the moment. So if we want to use subgraph, we'd have some more code.
okay. Yeah. So wishful coding, what I'd love to be able to do is say subgraph, my subgraph, do, and then just in the sort of subgraph context, maybe have like node. I am a node.
Yeah, I think that would work for the links. I think the nodes would have to be defined beforehand, because in Mermaid they're referenced. You're able to reference nodes from one subgraph on a different subgraph. So you would do all the nodes beforehand, and then just reference a binding to the node, which is a ref.
So are you saying the node, like the node has to be defined even outside the subgraph?
Yep. And then you would bind it to a variable, and then from that point on, you could just use the variable inside of the subgraph.
So I want to show you, because I thought that too initially. I was having problems with the mermaid syntax, and then I started playing with it in the live editor. And if you look at like start 3, this value, let me make this bigger, I'm sorry. So like this value representing a root process, a root task, is defined inside the location one subgraph. But
Yeah. No,
it's
in Mermaid, you don't have to redefine the nodes.
okay.
It just assumes that whenever you use the same ID for a node, it's referring to the same node, even if it's not previously defined in this subgraph.
Okay.
So that's a choice that I made on the version that I have on this flowchart code or Unison code, where in order to produce this ref that is more type safe, it's you have to predefine all of the nodes.
I see. Okay. So it's within the library. Got it. Okay.
Yeah.
Okay. That makes sense. Okay. Yeah, so that's going to be interesting because we've got this sort of need to communicate between subgraphs within the land of like mermaid. But it's almost like we need to have like a sort of parent scope that is being added to with all of the nodes as they're being kind of created, quote unquote.
Yeah. So the idea is that the links, as links are being made, we're keeping track of all of the nodes that are being referenced that haven't been referenced before. And then at the end, when we render the graph, we call these node calls before anything else, and then we start drawing the links. So even though in the syntax of the library you're supposed to define the nodes first, when evaluating the local remote, we wouldn't define anything yet. We would just keep track of all the things that happen, and then when we start to render it, we would collect all the nodes that were referenced, put them first on the rendering, and then the interactions.
Gotcha. Okay. Yeah. Okay. I see what you're saying. So it's almost like we're building up a list or a map data structure in the local remote interpreter. And then at the last step, we kind of do the draw.create or the, diagram.create step where we kind of zip it all together to create the graph. Okay. Cool.
Yep. It's almost like we're building a transcript, and then from the transcript, we can first collect all the nodes, and then render the interactions.
Yeah. Yeah. Okay. That makes sense. That makes sense to me. Yeah. Okay. So, but right now we need to add like just even a notion of the subgraph. Is that correct, Alvaro?
Yeah.
Okay.
I think what you have there as a starting point looks good. If you just move the node up outside of this node graph and bind it to value.
Okay. We'll call this root equals node. Okay, and then we can just reference it in the subgraph.
Yeah.
Okay. And let's do this. Okay. Let's see.
So I think we need to implement subgraph because I don't have it implemented as a part of the DSL yet.
Okay. Yeah. I wonder also, hold on. That's looking better. Okay. This is the error we expect. I don't know what subgraph means. Yeah. All right. Cool. So let's see. Where have you defined your sort of DSL?
I have an ability called draw flowchart, I think it's called.
Okay. Draw flowchart. Is it draw dot
or
flowchart?
float.
Create. Oh, it is called draw flowchart. Where? No, draw flowchart.
Yeah, it's called draw
It's on
flowchart. Oh yeah,
148.
there it is.
Where is it? Oh, it's
148.
I'm literally staring at it. Yes. Okay. So we're gonna need to, let's make this visible. We're gonna have to add a request constructor to the ability. Is that kind of the idea? So subgraph takes a text.
Yeah. Yep.
Oh, look at this. Copilot is drawing stuff for us. Does each subgraph have a direction?
It does. Yeah. Although it has some default.
Gotcha. I wonder if we should make it optional.
So far, I've not made any of the directions optional, but it is an option.
Okay. Okay. We'll stick with the style of the library. We'll be, stylistically coherent. Okay. So subgraph gets a label, and an orientation, and a list of nodes. Actually, I don't know if I love that. And returns. Yeah, I think it should return unit, but
So yeah, I think in this case it should return, or should take as a last parameter, draw flowchart effect.
yeah, it's like it. By as a last parameter, I guess. What do you mean by that?
So right now it takes a label direction, and then the next parameter, I think it should be a draw flowchart effect, so you can call things like link inside of it, returning a unit and suspended.
Okay. This is, this is really interesting because I actually haven't. The implied effect is also here in the UCM, right? Like it always implies that. So I've never actually seen an ability request constructor where the requirement of the ability is referenced in an argument as well as a return type. So this is interesting. And have you done this?
I'm wondering. I think I have, but I don't remember. Or maybe in the past I've implemented something like that outside of the ability. I don't remember, but I think this works fine.
Okay.
I think I've also had to do this, but it might have been me being bad at doing Unison. But I think I've accidentally done this
But
to get the compiler to be happy.
did it work?
I think so. I forget what I was doing. I think I was just trying to like parameterize like an effect or something that was using the same abilities, or I don't know. I'm gonna see if I can find it. I think it was in the Google Places library. I'll see if I can skim through it.
Okay. I mean, because it, like, to me, I feel like we should be able to do this. So if we can't, we should think about that. But we do want the like an argument to be the ability, sort of like a recursively defined ability requirement.
I just realized this might get a little bit tricky, because if we can define, or if the nodes have to be defined at the beginning, we probably don't want to allow nodes to be defined within a subgraph. So if we're allowing the node to take a draw flowchart effect, it would allow you to create or to define a node within a subgraph.
Yeah. And
And what I've done in the past is create another ability, but I don't know if it's worth it. But create another ability called like subgraph context.
I was thinking about that because I saw in your sequence diagram you have sort of like sub context abilities. Because how would we ever handle? How would we eliminate the ability requirement of draw flowchart if? No, okay. Maybe you
It
could.
might still work this way, as long as we don't try to call node or some of the non-subgraph things inside of the subgraph.
Okay. Well, one way to find out.
I just realized something else. Subgraph is also a thing that can be referenced via a link, because you can link two subgraphs
You can.
together.
Yeah, you can draw a line between the two.
And you can also specify metadata about a subgraph, like the label of the subgraph. So actually, subgraph needs to be defined before anything else as something that can be referenced in the same way as you did for node. For the, does that make sense?
It has to be like an entity, like I'm defining
Yeah.
the subgraph. So then how do you say that these nodes are inside of this subgraph? You know, like in this example where it's like, okay, location 1 is a subgraph, but it contains task 1 and task 2.
And you would do that after that definition. I think we're gonna need two things. One, ability function to define a subgraph as just a referenceable entity, and then one to define the actual.
Like subgraph context.
Wait. That's what I was thinking, but now I'm starting to question it as I say it. Maybe let's not. Maybe let's keep going the way we're going, and if there's an issue, we'll spot it.
Yeah, yeah, totally. And Tavish just linked something which might be an answer here. Okay, found this code
Which
that
is more
used
confusion.
Jason Reed in the and Jason Reed in the return. Yeah, I mean this makes sense. Like you could do. What does it? Let's see. Field read. Yeah. Okay. So I don't think we're doing anything illegal.
Not a crime.
Yeah, it's different though because this is like just a function versus an ability request constructor.
Oh, okay.
I think it's fine as long as it's not on the last arrow. Well, like you can't use another type of ability in the last arrow, but I think this is fine.
Okay. Okay. Let's continue. We'll forge ahead. We'll discover new things. And you know, if it works, awesome. Okay.
The text got a little too small for me.
In
Assuming-
yeah, is this better? Is that better?
A little, but it's still sort of showing the entire screen.
Okay, I wonder how to make this. Okay, one thing I could do. Oops. Well, now it's probably way too big.
Nope, that's perfect.
Is this better? Is this?
Well, maybe can you make the font size even bigger though?
Yeah. Oh no, I'm making Discord smaller miraculously. Eh?
Yeah.
Yeah? Okay. Well, folks, I feel like I'm in the Matrix. I'm just like surrounded by like giant text now. It's great. Okay. Cool. Let's make this fail to compile for the wrong reasons. And we said, all right, so our subgraph constructor, where do we put that? What was our type? Subgraph takes text orientation and a delayed computation of flowchart ability. Okay. So, in our main function, I want to be able to say do root, right? So, third argument to subgraph has type node ref, but I expected unit. It's delayed.
Oh, I think the problem is it really wants a unit to be returned as the function. So you'll have to add a new line and then add an explicit unit.
Okay.
So what's the root on line 178 doing right now?
Oh, I thought that node, maybe this is node. Let's take a look at what node does. Nope. I thought that node is in the sort of draw flowchart ability context. It takes a label, a shape, and it returns a node ref.
Which is just the ID, basically.
Okay.
So that line 178 isn't actually doing anything, is it?
178. It's returning a node ref in the using.
Well, we're not returning that, right? We have a node ref there that's doing nothing,
Yeah,
right?
it's not doing anything. I think in order for it to do something at the moment, I mean, we're probably missing some way to render a node without a link. But in order to make it do something right now, I think we would have to add a link, which would actually draw something.
Oh, okay. So right now, can you just have like a floating node in like in a subgraph? Is that a possible, I guess, representable thing?
Maybe not with this syntax yet. I think you can do that on a flowchart right now, just by defining a node.
Yeah, exactly.
But on a subgraph, I don't think you can have just the drawing of it. It would have to be triggered with something like draw node, or we'd have to create something.
Okay.
But just to see how, maybe we want to just create a link.
Yeah.
I know there's for rendering a link.
Yeah. Okay. Let's try and render a link. So should we have like a? Okay. So a link takes a node ref, an arrow style, and another node ref. Okay. Okay, let's try that. So link root arrow dot, sorry, default?
Arrow style.
Arrow style dot.
Oh, but the first parameter is a link style.
Ah, okay. Link style. Style dot.
it's a solid,
Solid. All right, let's do solid.
maybe.
Okay, root, default, task. All right. Link style, node ref, arrow style, node ref. And then another arrow style. Okay. Arrow.
And then I think I added a length of the node of the link, which is not being used right now. So you can probably just give it a 2 or something.
Oh. Okay. Let's see. So the draw flowchart.link function requires a terminal parameter called that's a length.
Yeah, it would be the length of the link, the line.
Oh, okay. So there's a link data type element, and then there's a link DSL sort of syntax. Okay.
Yeah.
So
Yep.
do I want the link data type element here?
No, the DSL link.
Okay.
So yeah, what you had before looked correct to me, because you're calling the link ability function.
With solid, a root, default task. So I see the length in the flowchart link.link data type. I don't see it
it's
in.
not part of the
Yeah.
yeah, it's not part of the ability function. We can probably remove it then from the call.
Okay. 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 Arrow style dot default. I probably made that up in my mind. So let's see. Arrow style. What type are you? Arrow style. We'll just call it arrow. Not default. Okay, let's run it. Decompiling a capture continuation. That makes sense because we did not add a handler. Ignore this error message. We know it's bad. Sorry. That's the one you get when you don't handle your abilities. So let's add a subgraph. Oh, thank you, Copilot.
Copilot was pretty good. I haven't actually seen it in action.
I didn't think that I would love our AI overlords as much as I do. But it's actually really helpful.
Worth paying for. I used it when it was free, and then they asked for money, and I uninstalled it everywhere.
Yeah.
The funny thing is, it's way, way better if you have it at the bottom of a file that has a bunch of Unison code in it. At the top of the file, it kind of sucks.
Yeah, isn't it like predicated off of code existing in GitHub, which Unison doesn't do except in like readmes?
Yeah.
I mean, as you're typing, as you're like writing Unison code, even if it's not on GitHub, is it like collecting the data from you?
There's a setting for whether you want to allow it to do that or not.
Okay. I let it
Letting it do that so we could get some Unison training data out there.
I let it have it for exactly that reason. I was like, well, I don't know if my Unison code is quote unquote idiomatic, but at least it's something. Interesting. Okay. So how does this handler, what does this handler handle to takes an orientation, the ability, and creates a flowchart. Flowchart element. So let's search for the flowchart type. Is the map of the nodes and the list of the elements. Right. And the element is a link or subgraph. Ah, okay. Well, we're going to need to make that subgraph. So there's that. Okay. And a subgraph contains the label, the orientation, and a list of elements. Okay. Okay. Let's see if we can't make that happen.
Yeah, this is where it gets a little tricky. Yeah.
Yeah, okay. So we know we're going to need to make like a subgraph of this type. That is optional. Yeah, this list of elements, that's going to be interesting. Okay. Ba-ba-ba-da-da-da-da. Okay. For the list of elements.
Here it gets a little interesting. So we have to convert the effect, the kind of like the subgraph content. I would probably rename that variable on 165 subgraph, the last parameter, to content or something on line 165.
165 content. Yeah.
Because here, or maybe even content effect, yeah, we have to transform that content effect into a list of flowchart elements.
Yeah.
For those of you that are calling the police, we are not holding you hostage.
This is where maybe we need another ability, a subgraph context ability,
Yeah.
and then a handler that all it does is just deal with transforming this effect into a list of links or a list of elements.
Yeah. I think like if the flowchart create effect created a list of element, we might have been able to recursively call the flowchart create effect, but because it creates an overall flowchart, I think it's too high, like it operates at a higher kind of level than the one that we would need. So I think we have to go back to that like sub-scoping idea that you had used in the sequence one. Okay.
I think so. Another option could be to just maybe as a shortcut to not create another ability, but just create another handler that simply crashes maybe on the non-subgraph context functions.
So we would be.
But I don't know if that's much. Kind of reusing a subset of the draw flowchart ability.
Huh. It crashes.
It'd be less correct.
Yeah, so in that sense, would that mean that we couldn't create, say, a link inside the subgraph, thing, or?
No, you could, but if you tried to do things that you should not be able to do inside of a subgraph, like creating a new node, that ability, or either it would succeed and ignore that part, or crash. It would be cleaner ultimately to have a separate ability, I think, for being in the context of a subgraph.
Okay.
We don't pay per ability, so we can create more.
This is true. This is true. But not yet. Maybe that's how we monetize cloud. Just kidding. Just kidding. This is recorded. Ah. So subgraph context? Huh? Yeah.
Yeah. And then I think the only thing we'd be able to do instead of a subgraph, at least right now, would be not create the subgraph, but create links inside of the subgraph. So the one you want to copy and paste is link.
Oh, so link is in the subgraph context. Link is the
Yeah.
core ability of the subgraph context.
Yeah. And then when we evaluate link, we can start producing this list of elements when we handle it.
I have a really perhaps simple question, or maybe I'm misunderstanding the notion of context here. So let's say I create two subgraphs, subgraph context 1, subgraph context 2. Am I going to be able to link between the two subgraph contexts?
Yes. If you pull up main again,
Yeah.
so imagine all the actual nodes are predefined as part of the create effect. So now if you have two subgraphs, you can reference those same nodes that are defined on line 183 and 184.
Right. Yeah, so if I wanted to create them, like create another node.
Oh, now I'm thinking, if the link is here, where does the actual node live? If the subgraph only contains the links, how does mermaid know on which subgraph to actually draw the node?
Yeah, that's what I'm wondering is like we need to in some way bind a node to a subgraph. So I kind of would want the ability to create a node inside a subgraph, if that makes sense.
How does that look like in mermaid?
That's a good question. So yeah, you can see this. Okay. So here inside this location one subgraph, I mean, I didn't programmatically create these nodes first, but I could.
Oh, wait. If a node is defined on the left side of a link, does that mean that node lives in the subgraph? And if it's defined on the right side, it means it could live elsewhere.
I think that's the case because if let's say if I say R1 root in here this location 2.
Yeah, if that's the case, I think we're okay. I don't think we need to define the node inside of the graph, as long as it shows up on a link on the left side of the link, it will be drawn on that subgraph.
Okay, so there's a strong sort of directionality component here where your node is bound to the left side in your subgraph Huh. Okay.
Yeah.
Okay.
So if you if you pull up, yeah, let's try defining like on the main file, even if though it's not implemented, a node. Um, let's see. So task, in this case, task would be drawn on the second subgraph, and root would be drawn on the first subgraph, just because they happen to live on the left side of a link defined in the subgraph.
So if I want, let's say I want task one to be inside my subgraph. Like it's inside this first
Then
subgraph.
it would have to, there would have to be a link in the my subgraph that has task as its start point.
What if it's a leaf node in the subgraph? Like it is pointed to.
That, oh yeah, I didn't think of that.
Because I'm
What does it look like on Mermaid?
I think it, like, if we kind of radically simplify all of these, let's just play around with like real simple. So like here, a subgraph, like this is obviously all within the location one subgraph, the root fork to task one. Task one is not on the left hand side. But it's still kind of inside the location subgraph. And I wonder, even if we create them outside the subgraph, I wonder what happens. Yeah, it still kind of shows up in the subgraph because both sides of the link are anchored in it.
Now, can you add another subgraph that has the second one, or a link to the second one, or maybe not a link, but just a reference to it, like just the node inside of it, the node on the right of the link on line 9.
No.
What if it's the beginning of a link?
If it's the beginning of the link, it looks back to the first location and says, I'm linking to this one.
Okay, so it definitely doesn't behave the way I expected. So how would you create?
So, just a question: what would happen if you linked to T001 from the new location? So basically, reverse this arrow.
Okay, let's do hi to, let's go test, yeah.
Okay. So I guess the nodes live in the first subgraph in which they are referenced.
Okay, that's a good principle to understand. The nodes live inside the first subgraph in which I can spell AR. Okay.
Yeah, I wonder if that's a property that we would maintain on this API. This
I mean, when we're drawing, I'm trying to think about like when we're drawing this subgraph. I imagine we'd want to like start a subgraph context and create both links and nodes.
the main issue with creating nodes instead of the subgraph context is if you want to reference them from outside the subgraph context.
Yeah, I see what you're saying. And I'm still not sure how to make two subgraph contexts talk to one another. Okay. Okay.
Another option that doesn't sort of match what Mermaid does, but it could be compiled to Mermaid anyway, would be to have an explicit list for each subgraph of the nodes that it sort of owns. I don't know.
Okay. Okay. I think there's something there.
But that might be tricky to render to Mermaid, because that means we'd have to make sure that when we render that one subgraph, it is the first one to reference any of those nodes.
When we render the
To
subgraph.
sort of trick Mermaid into owning those.
Okay. Okay. So I feel like there's something there in that, like when you're defining a subgraph, I think how Mermaid works is like the top ones, like there is an ordering kind of top down between which subgraphs get which nodes, right? Like even though I might reference node 1 in subgraph 2, if my first subgraph higher up kind of defined it or referenced it first, like I think we just saw that's kind of how it behaves. So
Can we try one more thing?
yeah.
If we, so I feel like there's got to be a way to specify who owns each node without having to rely on the order in which they're referencing. I wonder if you create two subgraphs with the same identifier, if it sort of merges them.
Like in Mermaid here.
Yeah.
Okay. So that would be. I mean, it does appear to defer to the first locations.
But give them both the same identifier.
Oh, like the subgraph themselves?
Yeah, and then add two different links. I'm kind of curious to see if it merges the two definitions into one.
Yeah, that's a good. Okay, so let's call this R2. And this is task 2.
It does merge them. Okay.
Okay.
Okay. That's interesting, because that gives us a way to control who owns it by having first rendering the subgraph with just the nodes that it owns without any links. Doing this for each subgraph, sort of just to determine ownership. And then separately drawing separate subgraphs that merge with the previous ones, defining any of the links. I guess those links don't even need to live in a subgraph.
Okay. So a subgraph has ownership of nodes, but not links.
I think so. So okay, maybe let's do one more experiment.
Yeah.
Let's use these two, but just to define nodes. So let's reference, let's say, A and B, just as nodes without any links. Yep, and then let's do on the next one B and C, or C and D.
Oh, new lines. Okay.
And in these, let's give them different identifiers. So now, what happens if we create links between these two, but outside of any subgraph? I think you gotta do 2 dashes on there.
Oh, thank you. Yeah. Okay, so
And now one within the same.
yeah, linking doesn't have any notion of subgraphs. It just looks for the identifier, the node ref.
Okay, this is interesting because in this case we could sort of determine ownership completely independently from linking, and always do all the links top level, right?
Yeah. That's I
That-
see what you're saying.
Would that be helpful or less helpful when programmatically defining a graph? I kind of think it would be helpful to sort of define all the nodes beforehand, define where they go, which subgraph owns them, and then creating all the links.
Yeah. I think I agree. Let me just think. If this is so for forking and awaiting tasks, I guess a thing that I'm thinking about in terms of the quote unquote linking is like a link for remote is I've started a task and I've finished that particular task. So like there's a timing element that I want to make sure that I'm not screwing it up. And I think it's okay. I think that's even desirable.
Sorry, you might have done an experiment on this. I got distracted for a little while. But does a subgraph necessarily own a node? Like, could you have like a Venn diagram where a node is right in the middle of 2 subgraphs and neither one really owns it?
I mean, I think this is kind of an example here where we've got this node and this task node defined independent of a subgraph. But then a node inside the subgraph, let's say A, can talk to that root node.
Right.
So what would happen if you tried to add, say, the node A to the second subgraph?
Let's see.
Would it just shout at you?
I think it ignores the second one because it was first defined in this one. But now if let's do a little test. Let's move this one above. Okay, so now there, yeah, so it's the first one sequentially on the page that gets ownership of the node.
Okay.
Okay. So we've figured out nodes live inside the first subgraph in which they are referenced. Links are not bound to a subgraph context at all. Like they can exist wherever. Okay.
So even though Mermaid allows you to put them inside of a
Which is probably
subgraph context.
some kind of convenience feature, right?
Yeah.
Like you can just
So,
write subgraph and write all the links that you need, and you're done. You don't need to split it up into multiple parts.
but if you start getting ownership issues, you know, then you would want to
Mhm.
split them up the way you, um, yeah.
Okay.
Yeah, I guess like you said, convenience, so you don't have to predefine those things.
Yeah. Okay.
But in our case, there is some benefit to predefining them. Um, the fact that we can use these refs.
Yeah. Okay. I wonder if
So maybe this could be simpler in the DSL. The the graphs could just maybe take a list of, or the subgraphs could just maybe take a list of refs. And then we don't have a subgraph context. We just draw links top level.
so with that. Okay. That would be something like I take in my subgraph takes a name, an orientation, and a list of nodes that exist inside the subgraph. Like that.
Yeah, I think so.
And
So
then
we're kind of veering from like the way you normally use mermaid, but that might be fine.
yeah. So it's almost like we are kind of creating a unison dialect of mermaid where like how you create quote unquote a mermaid diagram is a little bit different. I think as a starting point though, like, you know, make it work, make it pretty, that kind of spirit, like I
I
think
actually kind of like this in the sense that you could define graphs, and then after the graph is defined, you could start grouping nodes.
yeah, that's true. That's true. Which could be valuable for drawing sort of relationships between locations over time. Okay. Yeah. So that would look something. So this is kind of a syntax that we want to support, meaning we don't need the notion of a subgraph context because a subgraph is just positioning nodes inside of it. Like that's its goal. Okay. Let's go back and make that happen. Actually, this is nodes. And let's change the type of this to be a list of node refs.
Yeah.
Yeah, okay. Oh, I have to say flowchart dot node ref. Okay. So let's go back.
Oh, this is a little interesting too. I think you can have subgraphs instead of other subgraphs, right?
Can you have
so.
subgraphs inside of subgraphs? Probably. I feel like that's something you could do.
But what if you just put an identifier to a subgraph? Like lock2 instead of lock1.
Okay. So so you can define it inside of that, but you were saying
Yeah, what if it's defined top level and you add the reference to it?
I guess how would you this? I don't know if you can reference a subgraph. Can you? Because this is just calling it creating a node called G. Like it's not a variable name in the same way that like I think the nodes get variable names.
Okay, so maybe we will need to be able to define the subgraph inside of the subgraph somehow. But maybe we can do that after.
Yeah, I
Maybe at first version we don't do nested subgraphs.
is subgraph just graph all over again? Like, are they actually the same abstraction?
Sort of. I mean, I think part of it, one way you can think of that they're not the same is that a flow chart or a graph contains everything that's needed, but a subgraph could contain references defined in its outer scope or links to references defined in its outer scope.
I see what you're saying.
I don't know if that distinction matters that much.
Okay. I I feel like there's a strange similarity in what we want to do in the subgraph compared to what we want to do with the overall flowchart. So there's a part of me that's just like recurse, just somehow magically make the thing apply the graph handler all over again.
Yeah, maybe that could work. I think something that will make that difficult with the way I chose to implement this was that the handler for the subgraph tries to produce unique names for the IDs. And in order to do that, it keeps track of all the refs that had been defined. That way, when a new ref is defined, it can assign it generate a new ID for it.
Okay.
But that could be handled by having the handler take in a list of predefined IDs in case it's running in the context of another graph, I suppose.
Okay.
That way it can make sure to generate IDs that don't conflict with the ones of its parent. Yeah, maybe that's fine.
Well, I mean, I think that's like a larger change. We'll see if we can make the non graphy subgraph work first, because I think no matter what, this is going to be kind of a good component to have. It's just something that collects a list of nodes. So we're trying to make this. This is a list of nodes. Or what do we call it? Node refs. And we actually need flowchart elements. So how do we create flowchart elements from this? Let's see. Existing refs.
There's two constructors for flowchart. But no, maybe we don't want flowchart elements for a subgraph. Maybe we want to update subgraph to not take flowchart elements, since we won't be defining links in that context. It should just have a list of refs.
Okay. So this data type.
Yeah, we can probably just. Yeah.
So it should be a list of node ref.
Yeah.
Okay. Subgraph. Da, 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 da.
And I don't even know if this concept of the element where it can be a link or a subgraph makes sense anymore. Maybe we don't need it anymore.
Yeah, let's see. So if something is not a link or subgraph, but it's just a plain node, is that represented
Me-
lower level than this flowchart element?
I don't have a representation for that yet. So
Okay.
maybe instead of subgraph, maybe that's what we should have. Just like a drawn node, or I'm not sure what to call it.
Yeah.
Or maybe it should be called node. It's just in the context of element.
I feel like maybe, I guess there's probably something called node, element node. Well, we can add this
And
later.
then maybe we drop subgraph from this list.
Okay. So an element.
So what this means then is, at the top level, we have a list of subgraphs, a list of node refs, and we have a list of links. Or no, I'm sorry, a list of elements. So a flowchart would be those three things. I'm thinking. Well, what is it now?
Yeah, let's see. Flowchart. Where are you? Flowchart. Okay. So it's a map of text to node and a list
Okay,
of
that's what I was thinking. Just like, yeah. So maybe in between those two, we can add a list of subgraphs.
Okay, I'm just gonna add some notes. So this is the top level data type.
Oh wait, maybe the subgraph is already part of the flowchart node, so we don't need that list. Maybe. Sorry.
Okay, no worries. Flowchart node, let's see. The type of flowchart node is,
Oh, it is a subgraph with a list of flowchart. Oh, but okay, but that should be on line 38. Now it should be a node ref.
so a node is a node of a shape or a subgraph.
Yeah, and these are the things that can have references pointing to them,
Yeah.
or arrows pointing to them.
So would you say, in other words, that these are the sort of subjects of linking? Is the linking abstraction? Yes. Okay.
And those are the things that also have sort of properties that we want to predefine. Like at the beginning of our drawing, we say this subgraph's direction is top to bottom. This node's description should be this.
Okay. Okay. I see. Yeah, the data modeling to this is interesting. All right, so where are we in terms of our, let's go to 124. Okay, so we decided we don't want the subgraph to be a top level flow chart element because you can be a node.
I think so, yeah.
Okay. The fact that this is a map, what does this outer text mean?
It's because the links will have node refs at the endpoints. Oh, well, I was thinking that I was going to be looking things up in the map based on the node ref, but now I'm thinking that's not necessary, because it could all be predefined, and then the links just don't have to actually render any metadata about the actual nodes. So yeah, maybe it doesn't need to be a map. Maybe it can just be a list.
I'm kind of feeling like it is a list because the link element is inside, let's see. It is inside the element type. Right, so link is flow.
Yeah, this is a little confusing because I have a constructor of element called link. Maybe it should be called link element to make it clearer.
Okay.
Line 110 or element link.
Yeah, element link. So this one is, where did we put it? Is it? This used to be just called element. Oh, this one. No, that's not right. Okay, it was just called link, and we're calling it element link. So where?
Okay, and maybe we want to put documentation for this one because I keep forgetting where it is.
I know, me too.
And with names like element, super generic.
I know, node, entity.
Node, yeah.
Okay. So a flowchart element what is the element node abstraction of flowchart.element?
So it's something that triggers the drawing. I don't have a good way of describing it, but either the drawing of a single node or the drawing of a link.
The element node specific variant of flowchart element?
Yeah, so I think these concepts are merged in Mermaid, but in here they're separate. So on Mermaid you can draw a subgraph, you can draw a link, or you can even draw an individual sort of node thing.
Mm-hmm.
I think with this DSL, you don't really draw a subgraph. A subgraph just you define it as a grouping of nodes.
Okay.
The things you draw would be a link or a node, and then the subgraph gets automatically drawn. You don't trigger it in any way. It just automatically groups it based on the membership in the subgraph. So it's kind of a weird, subtle distinction. But like when using the DSL, you have to trigger the drawing of a node.
Okay.
And you have to trigger the drawing of a link.
Okay.
But the subgraph happens automatically based on membership.
Okay. Huh. Okay.
I don't know. I'm not convinced of it either myself. I'm still thinking about it.
Yeah. I think okay. There's something about like element and node that feel like they're talking about almost the same abstraction. But But I hear you in that, like, there's some really kind of finicky, like, details around what functions as what from, like, a library standpoint.
You know what? Maybe we don't need it. Maybe we don't need the element at all. Because instead of element, maybe we can just reference link.
Like flowchart.link
And
directly.
yeah,
I
and we will draw nodes just by having them be part of a subgraph. Well, I don't know. We still would need a way to draw them top level.
So to be honest, like I sort of imagine the flowchart type to contain like a list of nodes, a list of links, and a list of subgraphs. And each subgraph in turn has a list of nodes and a list of subgraphs so that you can nest them. Is there something missing, or is there a problem with that idea?
The main issue is with referencing nodes in one subgraph that belong to other subgraphs.
Huh.
So maybe we could go with that. We could go with that. You know, everything. You know, list of nodes, list of links, list of subgraphs, where the nodes are just node refs, and the graph itself, like the flowchart type, contains the actual like metadata about the nodes, like the actual definition of the properties of the nodes. But everything down the line, the subgraphs, they just have a list of node refs. And from going down that, it looks like exactly what you described.
And also
the list-
subgraphs don't have links. Only the top level structure has links.
Okay. Yeah, okay. So, if I'm understanding correctly, top level data type, flowchart, it's got an orientation because it needs it to make the graph. It's got a list of nodes. It's got a list of links and a list of subgraphs. Okay.
Another way to model the like the relation between nodes and subgraphs is to have a map from nodes to subgraphs, which just tells you like which subgraph the node is in, and also a map from subgraphs to subgraphs, which tells you which subgraph the subgraph is in, if you know what I mean. Like so, in an inclusion map.
Okay. I want to capture
That would be another way to do it, I think.
That's a really good idea. Okay.
I think I like the original version that you mentioned, where the subgraph has a list of nodes, but in this case they would be node refs, where node refs could be referencing subgraph refs. Yeah, unique types. Yeah, actually, I think I just want to study this type. Subgraph, text, orientation, flowchart, node ref. And node ref could reference a node or a subgraph, right?
If you really wanted to,
right.
you create a new sum type that kind of is either a node ref or a subgraph or something.
Yeah.
Or I guess it's a subgraph ref though, so I don't know if that's that useful.
There it is. Okay. A node ref is really simple. That's right. It's just the label, or the ID rather.
And it might label a node or a subgraph, right?
Yeah, I think so.
Okay. May label a node or a subgraph. Just contains the ID of the node. Okay. Oh, that's right. I have to say flowchart dot. We should really get that namespace directive working for Unison. Let's see. Does it not like my type? Could not find these syllables. Flowchart.node.
Oh, I think you have an uppercase C in flowchart.
Ah, thank you. I was like, I feel like I named it right. Okay, cool. We are back at 119. 119 here. Ah,
Wait, do we still have the concept of element?
so right now it's here. I don't actually know if it's used anywhere. Let's double check. It is when you add a link and when you to text something.
Can we reference just a link directly? I think so. I think we don't need to wrap it in an element.
Okay, these types are going to be kind of a little bit weird because this is no longer a map. So as we're adding a link, this is going to be nodes, this is links, and then subgraphs is nodes, links.
Yeah, this is an interesting exercise because we're trying to sort of match the capability and concepts of mermaid with what makes sense syntactically and semantically in Unison.
Yeah.
Does
With
mermaid
something
support?
that
No, please go on.
no, I was just gonna say with what we would expect out of a DSL.
Yeah.
Does mermaid support something like an empty subgraph? Is that a thing?
Huh, let's see. It does. Yeah, you can create just the name of a subgraph.
Oh, I was just thinking we could be tricky, and this may be what mermaid is doing anyway, and say a node is just a subgraph that has no nodes in it. If you see what I mean. Like they're really the same thing, only yeah. Because do you want? Can you add a node again to G?
There's one problem with that is nodes can be styled differently from subgraphs. So a node, you can set it to look cylindrical and a trapezoid and all those things.
Oh,
And you can't do that with a subgraph.
What is it? The syntax. No, all right, I can't figure it out. But
Yeah, you could try with like 2 circles. I mean, two parentheses maybe.
uh,
It doesn't like it. Oh, you have to give it an identifier, and then you're just missing the identifier. Yeah.
So as soon as you want to style it, you have to do the whole identifier thing.
Without any, so the identifier is by itself, just like a prefix to the. If you just remove the square brackets, I think it should work.
oh.
Okay, but still, it wouldn't hurt. Like it's not a problem if you say that the subgraph also has a style. It just gets ignored when drawing. One could do it that way. And I mean, as we saw, when you delete the node from the subgraph G, it just gets rendered as a node.
Yeah, that's
So
an
nodes-
interesting point.
Nodes are just trivial subgraphs.
Oh, yeah, I wonder if the. Okay. That's a really interesting observation. I never would have noticed that.
I'm sorry, guys. I have to step out.
Yeah,
But
Alvaro,
this-
thank you so much. Let's call it here because you've been so
Okay.
helpful with this. I am absolutely blown away by what you like. Literally last night, wrote up. It's amazing. So thank you so much. And it sounds like all of us have our own ideas about like how to model the mermaid Unison syntax. So
Definitely, yeah.
I'd be really interested in seeing like how people kind of do the data modeling, what kind of DSLs they come up with. I'm going to be working, on like how to do this too. So yeah, we'll pick this up next week.
Mm-hmm.
Awesome. Y'all have a wonderful, wonderful week.
You too.
Yeah.
Goodbye.
Thanks for joining. Bye.
Bye-bye.